Kia ora Year 12 and 11, here's question 2F from last year's school algebra exam. So this is what I call a disguised quadratic. It looks really horrible, but once we dig into it a little bit, it's not so bad. So the first thing we're going to do with it is to rewrite it with fractional powers so that we can see what's going on. So here we've got 3x to the power of 2/5 is equal to 17x to the power of 1/5 plus 6. So you look at that and it looks horrible, right? It doesn't look like we can easily solve it because it's these awful fifth root things. But then hopefully we notice that we've got a squared thing here and to the power of 1 here. Hopefully then you remember that sometimes we could do this. We could do a U-Substitution. So we're going to let U equal x to the power of 1/5. So that means that U squared will equal x to the power of 1/5 squared, which is x to the power of 2/5. And suddenly this whole thing looks pretty doable. So if you spot that, then what you can do next is make the U substitution. It's going to go like this. 3u squared is equal to 17u plus 6. So we're going to work this through with u, and then at the end we'll come back and change it all over to x. We're now down to what is a pretty straightforward quadratic that we're going to solve using grouping. As usual, make everything equal to 0. Now we want two numbers that times to give me -18, and those two numbers have to add to give me -17. So this is a pretty straightforward one because we know we're going to have some combo of 18 and 1, and we want it to give me -18 when we add them, so it'll be -18. -18 plus 1. So that tells me how to break up my quadratic. Let's change pen colour. So rewriting 3u squared minus 18u plus u minus 6 equals 0. Factorise the first two, 3u times u minus 6, and we're looking for this to be our repeated factor, so we've got plus 1 times u minus 6 is equal to 0. That gives me 3u plus 1 times u minus 6 equals 0, u equals -1/3, or u equals 6. So we're not quite done because remember we started out by saying that u is equal to x to the power of 1/5. So we're now going to rewrite it with x. X to the power of 1/5 is equal to -1/3, or x to the power of 1/5 is equal to 6. How do I get back to x? Well, I have to take this and put it to the power of 5. And I do that to both my solutions. And that gives me my final two answers, which will be -1 over 243. Now you can write that as a decimal if you want. It's -0. I can't remember, 0.004 something. Do a couple more significant figures than I've done there. And this one, 6 to the power of 5 is equal to 7,776, I think. Now I'm saying that from memory. I actually don't know 6 to the power of 5 in my head, so just check that that number's right. But I think that's right. All right, thanks for watching. I'll be back with some of question 3 later on today.